Hello and welcome to this video. We're going to look at the introduction to organic chemistry. In particular, we're going to look at the naming of organic compounds, just the simple organic compounds. Some organic compounds you may be familiar with are things such as amoxicillin, which is a commonly prescribed antibiotic. It's usually the yellow banana flavored liquid you get if you have an infection when you're young. Octane, it is a component of crude oil and is used in petrochemicals, and also quinine is an antimalarial agent which is found in tonic water and has proved very difficult to synthesize or to make. You will notice that there is a difference between the structures of quinine and amoxicillin versus octane, because in amoxicillin and quinine there doesn't appear to be any carbons, and we'll try and explain the reasons for that in a few minutes. Okay, so what we need to do is to look at the system of naming. We call it nomenclature in the world of chemistry, and it just means a system of naming compounds. So these names are different to a lot of chemical names because you cannot find the names or the logic for the names on the periodic table. You have to learn a whole new set of rules. Okay, so the set of rules essentially are this: that an alkane, which you're familiar with from GCSE, is made up of two parts. It's made up of the blue part here, which is called the stem, and the red part, which is the functional group. Because everything is an alkane, everything has the same ending, the same ANE. The blue part tells us how many carbons are in the longest carbon chain. Now we'll get onto that in a moment, about the longest carbon chain. But here we can see that if you've got methane, you only have one carbon in this formula. If you have ethane, so your stem is now an F instead of a meth, you've now got two carbons. And the logic proceeds that prop or propane has three carbons, butane, or if you've got the stem bute, you've got four carbons as your longest chain. Now those are kind of illogical names to try and remember, and so we've got here that methane's got one, ethane two, propane 3, butane, it's fallen off onto this line here, is 4. We have the mnemonic here, which is monkeys eat peeled bananas, or sometimes you hear monkeys eat peanut butter. It doesn't matter how you remember it, you've just got to know the names of these first 4 carbons. The next set of compounds in the family of alkanes, going from carbon number 5 down to carbon number 10, are more logical because the names are based on the geometrical shapes that you're probably familiar with, like pentagon, octagon, nonagon, decagon. The only one that's perhaps slightly anomalous is heptagon. Hept. So it follows then that if your compound your alkane has got 5 carbons as part of its longest chain, then it will be a pentane. If it's got 6 carbons, it will be a hexane. 7 carbons, octane. 8 carbons, octane. 9 carbons, nonane. 10 carbons, decane. The formula of the alkyl groups, that will be part of another video. Okay, so naming of hydrocarbons. Naming of hydrocarbons is really is made up of 3 different parts. You've got your stem, your blue part, which tells you the number of carbon atoms in the longest chain. Your suffix, your ending, which tells you your specific functional group. At the moment we'll be dealing with alkanes, and the prefix here in purple, which tells you which alkyl group you've got attached to your molecule. Okay, so here is the summary of the rules, and this is really, really important that you understand this, because if you can understand these rules and follow these rules, then you can essentially name any organic compound. Okay, so first of all, you identify what the stem is in your molecule, which is the longest carbon chain. The suffix, which identify which functional group you have. The prefix, you might not have a prefix. You might not have any alkyl chains or the functional groups hanging off your molecule. Okay, but sometimes you will. Numbers, now this is where it gets complicated. The numbers are used to show exactly where in the molecule the functional group or the alkyl side chain is. Okay, the carbon skeleton is numbered from the direction which gives the smallest number to the side chain. So it doesn't have to be from left to right going 1, 2, 3, 4. You could be counting 1, 2, 3, 4, counting right to left. You've always got to check for the smallest number. If you've got the same functional group or alkyl chains occurring multiple times in your molecule, then we put an additional prefix on to indicate the number of groups. So if you have 2 identical groups, you have a di, so you would have a dimethyl perhaps. If you had 3 identical groups, then you would have a trimethyl. If you had 4, say, ethyl groups, then you would have a tetraethyl groups. And then it goes on penta, hexa, hepta, as you saw on the previous page. Okay. When naming organic compounds, we should separate numbers using commas and numbers and words using hyphens. That'll be more obvious when we get to an example in a moment. And when a compound contains more than one different alkyl or functional group attached to the carbon chain, we write the names alphabetically, not in numerical order. Okay. If the suffix begins with a vowel, then the final letter of the parent alkane is removed. So we'll look at aldehydes, and you'll see that they become ethanal is an example of one, not ethanal. If your suffix starts with a consonant, the E on the alkane is kept, so you would have ethane dioic acid, not ethan dioic acid, for example. And then the last couple of points are the naming of the functional if you've got aldehydes or carboxylic acids, because these functional groups occur at the end of a chain, they are classed as carbon number 1, and their number is not included in the compound. And if an alkyl group or a functional group can only be in one position in the molecule, then numbers are not required. So 2-methylpropane is actually written as methylpropane. Ethanol is just written as ethanol. Okay, so just a quick go at a couple of alkanes. So here we've got example number 1. We've got a carbon chain. The longest carbon chain is 5 carbons long. So that means that the stem is a pent. Because it's an alkane, it's a saturated molecule. There's no carbon-carbon double bonds. It's an ane. Therefore, this is just simply pentane. Okay. In example number 2, we've now got a side chain. But first of all, we just ignore the side chain. We'll ignore these numbers, and the first thing we've got to work out is what is the stem. So 1, 2, 3, 4, 5 carbons long. Now, always check that you're counting the longest carbon chain. So you've got a carbon starting here, so make sure that you check that that isn't a longer chain. So 1, 2, 3, 4, 5. And believe you me, examiners will try and trip you up doing this. Okay, so it's a pent. Again, it's an alkane, so it's a pentane. But now we've got this additional group here. It's an alkyl chain, and it's got 1 carbon, so it's called a methyl side chain. And then, so we've got a methyl pentane. But we've got to decide on which carbon it is. It can either be on carbon number 1, 2, 3, 4, 5, so on carbon number 2, or if we count right to left, and we've always got to check 1, 2, 3, 4, 5. So it could either be 4-methyl pentane or 2-methyl pentane, but we always give the number from the end, which basically has got the lowest number. Okay, so this molecule will be called 2-methyl pentane. Okay, example number 3 here. Again, ignore the side chains, identify the longest carbon chain. So 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3. So the longest carbon chain is in the horizontal plane here. Okay, so it's an alkane, it's a pentane again, and we've got a methyl group here and a methyl group here. Okay, because we've got 2 identical groups, we don't write methyl-methyl, we write dimethyl, and we've got to number the position of both methyl groups. And this is a confusing bit because people go, oh, they're both on carbon number 3, so we say 3-methyl pentane. No. It is 3 dimethyl pentane. You have to use the numbers to identify where both of them are. Okay. You can pause the video if you wish and convince yourself that this is 3-ethyl 2-methyl hexane. Again, we've arranged the side chains in alphabetical order, not numerical order. And then just quickly onto alkenes. So here we've got an alkene, okay, because we've got a carbon-carbon double bond. Therefore, that changes our suffix. We then count our stem. It counts up at the number of carbons for our stem. So it's 1, 2, 3, 4, 5, 3, 4, 5. Okay, so it's a pent again. So it's a pentene. Now, because we've got the carbon-carbon double bond, and it could be in between carbons number 1 and 2, or between carbons number 2 and 3, or 3 and 4, 4 and 5, we have to state the actual position of this alkene. And so this alkene starts at carbon number 1. If it starts at carbon number 1, it's got to finish at carbon number 2. So we just use the lower number, and so we would say that this is pent-1-ene. Okay, so there you go. There's a quick introduction into naming alkanes and alkenes. Again, you can pause the video and look at the and read the information to decide which is this molecule. Is this a 4-methyl pent-2-ene or a 2-methyl pent-3-ene? Okay, thank you for watching.